Okay, so this is. Oh no. Sorry. Okay, so this is for lesson 1.4. So, one second, let me just organize myself. 1.4. We had a few things for 1.4. I'll be going off of my notes and stuff like that, so. Okay. Let's do 1.4. First off, let's start talking about domain and range, okay? So, domain is x values, and range is y values. Alright? So, once you have defined domain and range, you're good. You know what they are. You're set for the next few parts. So, first off, let's talk about the 4 ways. There are 4 ways for you to represent domain and range. Okay, D and R stand for domain and range. And the first one would be verbally. And that would be like, sorry, that's not, to represent a function. My bad. Okay, so the first one is verbal, which is just stating what type of function it is. So if we had like f of x equals to x squared, that's a square function. Okay? And if we had like f of x in the absolute value of x, that's an absolute value function. Right? So that's basically verbal. And for the second way would be numerical, which is by number. So let's say we have a table, right? And it gave you x and y, or it gave you input and output. So let's do this. So let's say this is x, this is y, and it gave you 4, 2, 4, and 5, 0, 7, 8. Right? So that's another way to represent a function, is by it being in a table. And obviously this would be domain, this would be range. Because y is always range and domain is always x, okay? And the second one would be graphically, so that's basically drawing the graph. The third one would be graphically, which is basically drawing a graph. And the fourth one would be algebraically, which is just by writing the function like this. Okay? Now let's move on to testing for a function. Obviously, not everything you see is going to be a function. So let me write this down. So let's say we have the flower brackets here, and we have -2 and 3, 0 and 0, 2 and 3, and 4, -1. Now, first things first is going to be stating out what your domain is, okay, to make it easier. Our domain would be -2, we have 0, we have 2, and we have 4, right? All the x values from the given coordinates. And our range will be all the y values, which would be 3, 0, 3, and -1. Let's look at the rule first. The rule states that for it to be a function, domain has to be unique. It cannot be repeated. You cannot have 2 and 2. It's saying that you can't have one x value going to multiple y's, okay? Because if you do, let's say they gave you, imagine that this is a straight graph. Imagine they gave you 2 and 3, and then 2 and 0, okay? The reason why this is not a function is because if we graph it, let's say this is 3, okay? So we have 2 right here. So we have 2 and 3 and 2 and 0. It creates a straight line, which means that the value is undefined. Okay, it gave us a vertical line. So this is not a function, okay? It's not specifically a graph. We see graphs, they could be curved, they could be going like this, right? So that's why you cannot have two x values that are the same, okay? However, you can have two y values that are the same. So this is something that I saw a lot of people get confused over for the past few years, which is that we have y repeated here, which is 3 and 3. They're repeated, okay? But that doesn't mean it's not a function. It is still a function because x is not repeated. So, because if you had, so let's put this graph here, okay? You have 2 and 3 and 4 and 3. So this is 2, this is 4, this is 3 up here. So let's graph 2 and 3, which would be right here, and 4 and 3. See, this is fine. It's okay for y to be repeated, right? But if it were to be 2 and 3 again, or 2 and 3 and then 2 and 0, it would be 2 and 3 and then 2 over here. So this would be it, right? It wouldn't be this or something else. See, so basically all you need to look at is the domain. Look at your x values. If they are repeated, then it's not a function. In this case, we don't have any repeated x values, which means this is a function. Okay? So as long as, I'll write it down here. As long as x is not repeated, it is a function. Always concern yourself with the x values, essentially, okay? So that's one thing that you have to know here. Now let's move on to the next part, which would be determining if something is a function graphically, okay? So you know how to do it numerically, where if it's like this, or if it's given to you in table form, it's the same concept. Now with graphs, if they gave you this graph, for example, oh no, that's not supposed to be there. Okay. They gave us this. So, or no, that's not the one that I'm supposed to draw. Okay. They gave us this, for example. Okay. There's something called the vertical line test. And basically, you take a ruler and put it on your graph like this. Draw a line. Now we see here that the line intersected or went through the graph at 2 points, which means that this is not a function. The vertical line test states that the line must intersect or must cross the graph once for it to be a function. So as long as the line intersects twice, that means it's not a function. If it intersects once, then it is a function. And now let's take a look at how to determine if a equation is a function algebraically. Let's start with this example right here. Y squared equals to 8 minus x squared. So we want to get rid of the square roots, the square, so we put it as a square root. So this becomes y equals to the square root of 8 minus x squared. Okay? Now because this was squared, that means we can have two possible solutions. So it's going to be a positive or a negative solution. So because of that, let's imagine that x is equals to 1. Okay. Minus 1. Which means that we're going to have two possible solutions, a positive or a negative solution. So we can have positive square root of 7 or negative square root of 7. And this means that this is not a function. Okay? So that's how you can determine it algebraically with the square root, for example. And let me take a look at this. Another example would be if you had y minus 4x squared equals to 36. So first off, isolate y. So we take 4 to the other side, which gives us 4x squared plus 36. And now take x as 0 by 0 plus 36, which means that y is equals to 36 because 4 times 0 is 0, 0 plus 36 is 36. So that means that this is a function. One second. There we go, that's much better. Okay, we can move on now. Let's go to evaluating functions. This is in the next part of 1.4. Evaluating functions, so they'll tell you that f of x is equals to x squared minus 3x minus 1. And they want you to find f of negative 2. So now all you have to do is take this and replace it inside of here and here and here. So that leaves us with f of negative 2 equals to negative 2 all squared minus 3 by negative 2 minus 1. Which leaves us with 4 plus 6 minus 1, and that gives you 9. Okay, so that's pretty much all it is for evaluating. Now, sometimes they'll tell you to evaluate it for another expression. So they'll tell you f of x is equals to 4x minus x squared, and they'll tell you find f of x plus 2. So now, same thing, it will give you 4x plus 2 minus x plus 2 all squared. Now for this one, it's pretty straightforward for this part. You distribute it. So you get 4x plus 8 minus, you have all squared here, which means that we can use the perfect square trinomial. So you end up with x squared plus 2 by 2, which is 4, and then x, because x is a, so it's 2ab, and then plus 2 squared, which gives us 4. And then you distribute this negative over here. 4x plus 8 minus x squared minus 4x minus 4, because you distributed the negative. And now you can cross these out, because negative 4x and positive 4x. 8 minus 4 is 4, which gives you negative x squared plus 4. Or you can rewrite it as 4 minus x squared. Okay, so that's how you evaluate the functions. Now, for the next part, it's piecewise functions. Piecewise functions are pretty straightforward. They're pretty easy to understand once you see them explained in a certain way. So let's imagine that we have f of x is equals to, you have x squared plus 1, x minus 2. Piecewise functions are basically like if statements. They're telling you that if your given x is a certain inside a certain range, then you use this function, or you use this function. So for example, for x squared plus 1, it tells us we can use it if our x value is smaller than 0. And for x minus 2, it tells us that we can use it if our x value is greater than or equals to 0. So if they give you f negative 1, f of negative 1 is smaller than 0, which means we can use this first function, okay? So you look at this, and if it's fitting into here, then you use the first function. If it's fitting into here, then you use this one. So this means that it's going to be negative 1 squared plus 1, according to what our statement says, which gives us 1 plus 1, which gives us 2. If, for example, you had f of 0, here it tells us for the second expression to be used, x has to be bigger or equals to 0, which means that it's going to be 0 minus 2. We replace this with 0, and we put in the rest of the equation, which gives us negative 2. Alright, so that's piecewise functions. Now it's about finding the domain of a function. Okay? And of course we have different types of functions, and each one is different for finding domain. Now first off, let's start with rational functions. Okay? Rational functions. So if they gave us f of x is equals to 4 over x, and they told us to find the domain. Now in this case, we know that for this to be a rational function, x cannot equal 0 because x is in the denominator. Right? So x cannot equal to 0, otherwise it will be undefined. So now that we know that domain is going to be all real numbers except for 0. So this is how we write it. We write it as negative infinity, 0, union, 0, positive infinity. Okay? And another example, if they gave you f of x is equals to 3t over t plus 5. So here in the denominator, we have the expression t plus 5. We know that if we put negative 5, okay, if we put it as negative 5 plus 5, it's going to give us 0, okay, which we do not want. So we know that negative 5 cannot be included in the domain, which means that our domain would be equals to negative infinity, negative 5, union, negative infinity, sorry, negative 5 and positive infinity, okay? Now let's move on to polynomial functions. Oh, sorry, hold on, one more example. This next example, we're going to have two values that have to be excluded from our domain. So we have f of x is equals to x plus 2 all over x squared minus 1. Now, because this is squared, we know that there are two values that we cannot use, which are going to be negative 1 and 1, because if we put them, they're going to equals to 0. So our domain is going to be equals to negative infinity and negative 1, union negative 1 and 1, union 1, positive infinity. So in this case, we have two unions because we have three things to write in the domain. So essentially here, because you excluded two values, you want to put them in their own coordinate. But that's pretty much finding domain for rational functions. Now, what about polynomial functions? Polynomial functions are a lot easier to find in terms of domain, because here's an example of a polynomial function. X squared plus 3x minus 1. See here, no matter what number we put in x, there is no way that it will give us something that will make the function undefined, which means that the domain for polynomial functions in general is all real numbers, which is negative infinity and infinity. Most case scenario, like 99% of the time, domain for polynomial functions, which look like this, they could look like quadratic functions, is going to be all real numbers, which is going to be negative infinity and infinity. And the last bit is the square root functions. Okay? So for square root functions, it's pretty simple. You have f of x equals to the square root of x minus 3. What we have to do is take what's inside the square root and make it greater than or equals to 0. And then we can take this and move it to the other side, which gives us x greater than or equals to positive 3. So in this case, positive 3 is included in the domain. We can use it as an example of the range of the domain. So we write it as this bracket. Okay, oh no. We write it as this bracket, and it's gonna be, hold on. Oh my god. 1 second. Okay, so for this one, 3 is included in the domain, which means that it's going to be this open bracket. It's really important that you use this open bracket, not this. This is wrong, okay? Because we want to make sure that 3 is included inside the domain. So it's going to be 3 and then positive infinity. And then you close it with the parentheses, okay? So it's really important that when you're doing the square root domain, you put this when you're including this numerical value. And then the last bit of 1.4 is the difference quotient, which is super, super easy. You just need a little bit of focus, okay? The difference quotient. So first off, let's look at the formula. The formula says that f of x plus h minus f of x all over h. And h cannot equals to 0 naturally, because h is the denominator and we can't have that equals to 0. So for example, they gave you f of x equals to 3x squared minus 5x plus 4. So the first step is, we see here that we have the value of f of x, we have the expression, but we do not have x plus h. So what we need to do is, we need to substitute x for x plus h, like we do in evaluating them, remember? So now it's going to be f of x plus h. We have 3, and then we have an x down here. So we can do it as x plus h, all squared, because this is a square, minus 5, and because 5 has an x is going to be replaced with x plus h plus 4. Okay? So right now you're solving for this, you're evaluating this. So we cannot distribute 3 here because this has square. So we can use the perfect square trinomial. So this is going to stay this 3, and this is going to turn into x squared plus 2xh plus h squared. And then minus, here, because there is no exponent, we can distribute the 5, okay? So because there's no exponent, we distribute the 5, so that's negative 5x minus 5h, and then plus 4. So now that we have this, we can distribute the x. This is going to become 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. So here, there is nothing to cross out. There is no positive 5h for us to cross it out with this one. So now that you have the value for f of x plus h, you want to take it into the difference quotient, okay? dq is equals to, we said f of x plus h, which means that we need to write this entire equation, this entire expression here. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. Granted, it is a little long, but that's the only way to do it. And then we subtract it here by the original equation. So minus 3x squared minus 5x plus 4 all over h. Okay, so now that we have this, I'm gonna have to take it down here. Hold on, let me rewrite this. 3x squared, 6xh, 3h squared, no, 5x, 5h plus 4. Okay, minus the original equation, 3x squared. Oh no, don't do that. Minus the original equation, 3x squared minus 5x plus 4. Okay, so what you want to do now is distribute this into this set of parentheses. It is really important that you put them both in parentheses, especially because you have a subtraction sign here. So now this is going to be equals to 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. And now we distributed this negative sign, which means this positive 3x is going to be negative 3x squared. This is supposed to be squared. Positive, so negative and negative is going to give us positive 5x. And then negative and positive is going to give us minus 4. All over h again. Okay, so now let's take a look at this. Can we cross out anything? We have negative 3x squared and positive 3x squared, so this can go. And then we have a positive 5x and a negative 5x, so this can also go. And now there's one more. Negative 4 and positive 4, these can go as well. So now you're pretty much left with 6xh plus 3h squared minus 5h all over h. Now we know that we don't want h to be negative, or sorry, we don't want it to be a 0, so we can factor out h from the numerator. So this becomes 6x plus 3h minus 5. And then you just cross these out, and your final answer is going to be 6x plus 3h minus 5. Okay, that's pretty much all of 1.4. After I'm done recording 1.5 and I'm going to send you guys the link and everything, I will send in this entire document if you guys want me to. Okay, so that's pretty much all of 1.4. I'll do 1.5 later on and I'll send it hopefully tonight.